clap. And I'm going to share my screen. This one. So anyway. So today we are testing for different types of carbohydrates and trying to classify them. So he sent out an email with some information. He gave you guys there should be a sheet that has, let's see here, it's in here, unless he emailed it to you guys, but there should be a sheet that's this one. So we're gonna go through the video, and you're gonna do a positive or a minus. And a positive test is when it turns a murky brown, and a negative is when it doesn't turn a murky brown. So you're gonna get all that information down right from there. Then he sent out an email of your unknowns. And from this information here, you're going to use it to determine what your unknown is. And he said he sent out like some kind of flow chart for you guys to use in order to put in the information, which I think you put into this data sheet here. Does that make sense to everybody?
He did send us the information, but I was looking over it and he didn't give us like final color changes on like Silo-1-offs or Benedicts or something.
Is the person talking have a video? Did any of you guys print it out?
I don't have a video, sorry.
It's fine. Okay, let's see. Let's go through this email real quick. Where he sent it out. It's not unknown. So there's no yeah. So in the unknown though, he does have the color changes for the bials. So brown, blue, right? So like for one of them,
I see that.
If your last name is there, so someone wrote something in the chat. Be right back. Boss is calling me. Ooh, sounds like it's not good. It says, yeah, you have everything that you need. You just write down your unknown code, and then based on the thing that we see with this, you're going to see which ones are positive for. So, for example, for the MOLISCH test, xylose, fructose, glucose, lactose, sucrose, maltose, right? So, it's going to go like positive or negative, And then as you go through that, you're going to look at your unknowns. You're going to go, okay, my last name begins with A. The MOLISCH test was positive. Was xylose positive from MOLISCH? Oh, nope. Okay, then it's not xylose. Okay, let's go to the next one. And then so on and so forth.
Right, I get that. It's just with the Silo-1-offs or whatever, doesn't the color of the product determine if it's an aldose or a ketose? And then same with if it's non-reducing or reducing. And since we don't have those colors, we're not going to be able to like really nail down what our product is.
Did he send you anything for the Silo-1-offs?
He did, but he just indicated that we're having a positive reaction, and it looks like what matters with those is the color of the reaction.
Well, they're not all positive for it though. So they're not all positive for Silo-1-off. So I would say that if it's positive, then there was a color change. Does that make sense?
I mean, yes, but it looks like from that flow chart we have in our lab book, it matters what color change it is. It's either going to be green to peach or then cherry red.
It changes to cherry red. So cherry red, I think, would be the positive. When I flip back into the Silo-1-off section in the lab manual, It says it goes to a cherry red product within 2 minutes or 10 minutes, I guess. That's the
Does that make sense to everyone?
not the yeah.
Okay, and we're going to go through the video too, so we can see it. But I just want to explain that to everyone. Did that help you though? Who was just asking that about that?
It's Laura.
Laura, does that help you?
Not really, but it's okay.
Okay, sorry. We'll get through it though, don't worry. Okay.
I think you're actually right anyway, Flora. It reacts to change either color depending on if it's ketose or aldose.
Yeah, what I was trying to say is that we need a color regardless, so if it's an aldose or a ketose.
Right.
I mean, all we do know is that it's a reducing well, I mean, they have different ones, so.
Where is the other video? Hold on, y'all. I don't see his lab video. Oh, I told him that it released it. Hold on, guys. I told him that we're starting at 1:30, so I don't know why the video's not up. Wait for a second. Wait, didn't somebody say that the video was already posted?
Yeah, it's on there at the very bottom.
The positive and negative for BARFOED'S is weird too, because it's going to be positive either way.
But you said
It's
on the
just a matter of
very,
how long
the very
it takes.
Oh, here, is it this one? Right here, I thought we're doing 0466.
No, we're doing 0446, qualitative.
0446.
carbohydrates.
You're right, Trey. BARFOED'S, you have to wait a full 10 minutes for a full reaction.
Or 2 to 3 minutes, but it's not like positive.
Oh, you still have to,
and
you
negative.
still have to monitor it for a full 10 just to be able to see if it's going to change for the final disaccharide.
Yeah.
I don't see 0446 anywhere in here in his list of videos.
Wait, 0446?
Uh-huh.
Yeah, it's online. It's video 14 at the very
Give them the
bottom.
link, would you please, Laura? Jenna?
Bottom. There's a lot of videos though.
Yeah. Can you send a link or something in the chat?
Yeah, I'll do.
I don't see it.
Hey, Quinn. Quinn.
Be able to open it?
Let's see. Yep. Cool, thanks.
No problem.
Oh, it was posted April 22nd, 2020. Okay.
Nothing.
Cool. So, do you guys see the video? Assuming you do. Whoa. That was loud.
So this is for the first row, right?
This is for the first row, I believe, yes. I haven't seen the video yet, so I don't know exactly how it's doing it. So it says transfer 2 mils of the carbohydrates from the first set to the second set. So add 2 drops of MOLISCH reagent and mix, and then add 2 mils of concentrated sulfuric acid to the third set. This is pour the carbohydrate MOLISCH reagent from the second set to the third set. Observe the layer. Name of the carbohydrate left to right: xylose, sucrose, starch, maltose, lactose, glucose, fructose. So is that what you guys have on your sheet?
Yeah, but not in the same order.
Not in the same order? Okay, well then I guess we'll just pay attention to which ones are changing colors and which ones are not. Oh no. This posted in viewable. Okay. So that was not very. So sucrose, starch, maltose, lactose, glucose, and fructose going from left to right. And then there's xylose right here on its own. So it looks like only sucrose turned to a brown color. And then looks like fructose might be turning brown. Let's slow this down. This is going too fast. So do you guys see that? And this is for the MOLISCH reagent.
So would you say that the one on the very right is positive or negative?
I would say it's positive.
Okay, and which one again?
Which one is that's I want to say that's, sorry, hold on.
It's fructose.
Yeah, fructose. Oh, come on, dude. Sorry, no, this is. So yeah, that one was fructose on the end there. How does he have music? Okay. Now I do the to touch my edit. So he said from left to right is fructose, glucose, lactose, maltose, starch, sucrose, and xylose. So what do you guys think? Do you guys think that only the, what is that one right there next to the sucrose?
Like only
Starch?
a positive reaction.
Yeah, it's like only starch had a positive reaction, right? Okay. Did you guys get all that down?
You guys want a really good laugh? If you look at the heating plate that he uses, that's my company I work for.
No kidding. That's pretty cool, actually.
Anybody want some really good quality lab equipment for a good price? I have ins.
All right.
Sold.
Let's call you Little Walter.
All right, so we see here that we added 3 mils of the BARFOED'S reagent to 1 mil of the test tube and placed the test tube in boiling water for 5 minutes. Does he say? Yeah, so I think he says what the list is. Looks like it says fructose, glucose, lactose, maltose, starch, sucrose, and xylose. And I want to say this is after the boiling, but let's see. Oh, no. So it's in the boiling. So. Record the time, place, and so time. So they went to 112 degrees, 5 minutes. So it says record the time, place tubes with no precipitate back, and record the presence of red precipitate, and then what? The name, okay, so from left to right, starch, fructose, lactose, maltose, xylose, sucrose, and glucose. So I don't see any red precipitate. Oh, we're gonna do that next.
So should we put like negative for this is the BARFOED'S, right?
Yeah, so let's hold on a second. Let's see what happens after this.
Okay.
Because I want to see if it's. So yeah, because this is all the BARFOED'S reagent. Is that how you say it, BARFOED'S?
No. Yeah, I see the red precipitate in 3 of them.
Yeah, so you see it now. Yeah, so you see in looks like fructose, glucose, and xylose. I see red precipitate, and the other ones I do not.
So should we put that in the initial or in the final?
So I would put negative in the initial, and then
Okay.
positive in the final.
Alrighty.
10-minute elapse, right? We did for a full 10 minutes.
Yeah. So it's 5 minutes, and then they stopped, and then 10 minutes. So here's Solowanov's test.
So which ones were positive?
Fructose, glucose, and xylose. Everyone got that?
This was after the 2 to 3 minutes or after the 10 minutes?
After the 10 minutes.
Okay, so nothing had a red precipitate in the 2 to 3 minutes?
In the 2 to 3 minutes. From my understanding, he did it for 10 minutes. So where do you see 2 to 3 minutes?
Well, I was looking at what the results say. We should have a red precipitate within 2 to 3 minutes if it's a reducing monosaccharide, and we should see a red precipitate after 10 minutes if it's a reducing disaccharide.
Okay, yeah, because there was no 2 to 3 minutes. It was just 10 minutes.
Okay, so then just basically if we saw a red precipitate at all.
Yeah. Because he does it for 10 minutes, and then, so this is after the total 10 minutes here. So I would say that, so what did you say, that after the 10 minutes, it should be a disaccharide?
Yeah, if we waited 10 minutes and saw the red precipitate, then it would be a reducing disaccharide. But if it formed within the first 2 to 3 minutes, then it'd be a reducing monosaccharide.
Okay, yeah, so I think that in this case, they would all be disaccharides. Because they didn't, the ones that did turn red would be, because they didn't turn red until 10 minutes after.
So for the final line on that thing, for the BARFOED'S, on the elapsed, what are we going to put on that? We don't put the time that it actually went positive or negative, or are we just going to be like positive, negative on it? 'Cause it's got final, initial, and elapsed on the.
So initial should be negative, final should be positive, and then elapsed time should be 10 minutes.
Just want to make sure.
Yep, no, you're fine. So you're gonna transfer the,
Also, what about the line above the final, the BARFOED'S time? Like, what do we put in those lines?
I can't see the paper right now, but what does it look like?
This?
Hold on, let me.
That helps.
Okay, so BARFOED'S is line. Where's this line above it? You said final. Oh, yeah, I don't know. I don't think you put. I think that's where you put the positive or negative, I think. Yeah, I would just not even worry about that one. You only need to put a positive or negative, so that just might be just be like an extra line or something. So you're going to put 9 mils of cellulose reagent, 2.5 minutes. It's just kind of weird that this is all done in like still motion. You know, it's not like a video can actually doing it.
That's probably why he added the music.
Yeah, probably. Well, I guess here's, oh, now he's actually. So yeah, you guys had mentioned something about whether if it turned cherry red or brown, and if it was an aldose or a ketose. Lauren, I think you were saying that.
Yeah, it's supposed to turn cherry red if it's a ketose, and blue green, then peach if it's an aldose.
Okay. These aren't really reacting that strong. So let's go back, because I did not get anything from that at all.
So does that mean fructose is the only positive there is, or is that what other one that is?
Yeah, because it looks just like, yeah, it just looks like fructose and maybe sucrose. What did it say? Sucrose there?
Those are the peach ones.
Yeah, I mean, it looks like fructose is the most peach one, though. Does it not look? Does it that not seem like the case to you guys?
Yeah,
Yeah.
the
So
sucrose has got a very light pink to it also.
yeah, it has a light pink to it too. So I would say that that's also positive for that, and it turned to that peach color that Lauren had mentioned.
Is that under the final line?
Yeah, because it looks like after this, after this step here, it's going to be done. So. Let's see. So yeah, fructose and sucrose. So yeah, that was it. That was. So yeah, after the 2 minutes, we're gonna see what our observations are. 2, okay, great. So, man, starch, so left to right, starch, maltose, lactose, sucrose, fructose, glucose, and xylose. So it looks like they're all, except for, what does that say? What was the third one? It was fruit. Is that fructose there?
Maybe, yeah.
Let's see. That's the 1, 2, 3, 4. It's one down.
I thought I had bad handwriting.
2, 3, 4. So that's sucrose. I know, right? Yeah. Looks like that's sucrose there. That didn't have that orange layer on the top.
So then sucrose would be the only negative one?
Right.
Okay.
So some are yellow, some are dark orange. Oh, it's turning like, oh. You should have like some clamps or something to pick those up, but not with your hands.
My inner safety supervisor makes me want to scream out of this video right now.
Right, yeah.
Ever hear the name Steve Kushner?
Steve Kushner, isn't that Ivanka's husband?
Oh, no.
Oh, that's Jared Kushner. Never mind.
Yeah, Steve Kushner, Kutzner. He's one of the leading living fossils that are still in chemistry. He tells us craziest stories of some of his buddies who did crap like this. One of them, he's like, yeah, I shook his hand like this. Got magnesium splash on his hands.
What is
Oh,
that?
wow.
One of his buddies, this guy is 74 years old, teaches at ACC, is known some of the greatest amazing chemists in the world. And one of his buddies was working on something he wasn't willing to talk about. And he said, yeah, he splashed himself with a magnesium solution. And when he met him the next time, he could only shake his hand like this. You know, like, that's all he had left.
Wow. Oh, wow.
Yeah.
Well, there you go. That's why it's important.
That, never throw a block of magnesium in the Ohio River.
Oh, there you go. Why? It might explode or something?
Oh, it did, yes.
Okay, nice.
Called out the state troopers cause of it.
Wow.
That's what happens when you get your doctorate in Ohio.
All right, there you go. So I'm not seeing much color change as this is going on. Most of them, I think, are just staying the color that they were. Maybe I can speed up this process. So we're gonna go back through this step one more time, or just this last part of it. Make sure we get the colors down. Ours is like a deep yellow. I think that's fructose. I'm hoping he puts them like on like a rack where we can just look at them. Xylose looks like a deep blue, I think. Glucose looks like a deep, like golden yellow. I think that's, I don't know, I can't read that writing. Okay, cool. So let's see what we got. Fructose. All the colors kind of look the same now. Almost. So fruit. So that looks like fructose. Looks like dark yellowish brown, right? Did you guys say so? Okay.
So would that be positive?
I don't think for this one you put positive or negative. I think it's just brown. I think for this one you just put the color. No. Does it have like the same kind of? Huh?
This is Bales, right?
Yeah. So for this one, I believe you just put the color because they all kind of change color, right? It's not like a colorless type of deal.
Oh,
so I think it just
Pentos gives a blue, or green condensation, and then hexoses yield the muddy brown to gray condensation product.
Right. So
Kind of helps you identify it, I guess.
whoa, what the hell? He just went through like that one. So it looks like, yeah, I mean, they all look like the same color, except for maybe xylose. I know that xylose looked a little bit more blue. And then you got maltose there. Looks like just kind of a dirty brown color. Lactose also. Yeah, so just put whatever color you guys think it is, because yeah, to me, like they all look the same, except for xylose looks like a little bit of a dark blue color. Okay, so did that make sense to everybody? Kind of. All right, so, and another thing I want to talk about with you guys are just some of the hazards of the lab. So, you know, like the MOLISCH reagent is toxic and corrosive. The iodine, potassium, the iodide reagent is highly toxic, corrosive, and an irritant. The BARFOED'S reagent is corrosive and an irritant. Biles is toxic and corrosive. Benedict's toxic and irritant. Seleno's toxic and corrosive. Just assume anything that's not like hexane or ethanol. Even those might be harmful to you for a long-term exposure, like on your skin, like direct contact. But all these are always going to be something that's not fun to play around with, especially the iodide reagent. And so let's just look at this flow chart here. So does this look like the flow chart that he sent you guys?
That's the one
That's in the
lab
book.
manual.
Yeah, this is in the lab manual. So does this look like the one that he sent you? Or is this the same one that he sent you?
I don't think he sent this one.
Yeah, he didn't send a flow
Oh,
chart.
he said he was going to send you a flow chart. Huh.
No flow chart, just the positive, negative results.
Okay, yeah, that's weird. He said he was going to send you one. So maybe this is it. Maybe this is the flow chart that he was talking about. Because I think though the thing was, he said that some of you guys still don't have books. So maybe he posted this to Canvas. Do you guys have access to this on Canvas, like the lab manual?
I didn't see it. I uploaded the
Just-
entire manual though on group.
Yeah, and thank you for that, Sean. Really appreciate that. But he said he was going to post this for you
Oh,
guys.
it is posted on Canvas. I see it.
Okay, so then there's that. I think this is the flow chart. So MOLISCH test. So if there's no reaction, it's a non-carb, and if it's a purple product, it is a carb. Okay, cool. Okay, well, what kind of carb is it now? Okay, well, let's do the iodide test. Okay, well, we got blue black. Okay, well, it's a starch, and it stops there. Okay, well, there's no reaction. Okay, well, then let's see what kind of, it's a carbohydrate. That's not a starch, so like we'll see what kind of a carb it is. Okay, the BARFOED'S test. Okay, red precipitate after 2 to 3 minutes. It's a monos. See, but I didn't see any precipitate after 2 to 3 minutes. So I don't know like which one that's supposed to be, but unless you guys saw something else, they all should go to the 10-minute one. Does anyone disagree with that? Because I didn't see it. Maybe I have to rewatch the video, but I didn't see anything like that. So anyway,
According to the video, I would agree with that. Yeah.
yeah. So after, and also too, he said something about like also Googling it and seeing like what it should be like in theory, not just based on this video. Yeah. Yes, Trey. I know.
Because like xylose is a monosaccharide, but it tested out as a
right. Exactly.
disaccharide.
Right. So it could just be like an error of the lab, right? Like not everything's going to work perfectly. And trust me, if any of y'all are going into research, you guys know that things don't always work out perfectly every time for whatever reason. It was just bad luck that day, right? And it is 2020, so you know it's been a bad year anyway, right? So well, overall. And then so anyway, so then the precipitate comes after 10 minutes. So then we do the Benedict's test, and we see if it's a reducing or non-reducing sugar, and if it's red, it's a reducing sugar, and you stop there. And also, I mean, either way, the Benedict's test is a dead end test, right? After that, there's nothing else. But if there's no reaction and there's a precipitate after 2 to 3 minutes, it's a reducing monosaccharide. And we go to the Seliwanoff's test. And if it goes from a blue-green to a peach product, like Lauren pointed out, it's an aldose. And then from there, you say, okay, is it pentose or hexose? Okay, blue or green product, pentose. And Biles test, muddy brown, gray product, hexose. And then if it turns to cherry red, it's a ketose. And so, which this is a little confusing because it's like, why are there two, like, how is this a aldose and then a ketose? Whatever, that's fine. Because aldehydes and ketones are different. So you have also pentose and hexose. That's okay, whatever, it's fine. Yeah, and then you just, that's it. Sorry, I repeated myself there. But yeah, so does this make sense to y'all? Like, does it, I know y'all probably are gonna have to go back and rewatch this video. Like I said, I didn't even know it was posted yet, so I didn't get a chance to watch it beforehand. Apparently he recorded this because, I mean, if you guys can tell, like all the videos up until now have been, you know, recorded this semester. So they're more recently posted. So, you know, I know where to look, but this one, I couldn't find it. And yeah, so does anyone have any questions? I'm gonna tell y'all right now, this lab for you guys is it's very easy. It's very, I'm gonna stop sharing. This is a very, and I'm gonna stop recording.